Well, hello, everybody, and welcome to From Foundation Models to Fine-Tuned Applications. Today we're going to jump into exactly that. We're going to show you kind of a quick, let me go to the next slide. There we go. So this is the quick agenda that we're going to be looking at today. So first, we're going to start off with a pretty simple introduction to large language models. We're going to keep this pretty light because every once in a while we have some people who are just new to the industry in the room. Then we're going to go on to what building a QA system with large language models looks like. And then we're going to start digging into Label Studio and how that connects into the whole kind of ecosystem of this simple QA system that we've built. Then we're going to move on. We're going to move on to a demo of this, seeing it in action, and then we're going to kind of broaden our aperture of what we're doing there and then do some Q&A. So with that, let's get started. So this is kind of just a sneak peek of where we're going. Use it as a little bit of a spoiler or maybe even a trailer for kind of the trajectory that we're on. But what we're going to be doing is fine-tuning a QA chatbot to answer questions about Label Studio. So you can kind of think of this as if we're seeing this more and more where you could have a chatbot right inside your Docs application or something like that. And you can actually ask it questions for anything about your product, and it comes back with hopefully something relevant. And so we're going to be talking about not only how you would create a very simple version of this, maybe not ready to deploy, but a simple version. But the most important thing is how you're going to tune that over time, because things are going to be changing. So this is more just a trailer of what we're going to see by the end, and we'll jump into an introduction to large language models. So if anybody, I'm assuming probably most people are at least familiar with the term ChatGPT and just generative models or even language models in general. There's a lot that we could go into here, but I want to keep it super, super simple and high level because this is going to be useful for our purposes. So when people usually ask me, like non-technical people who aren't in the industry, what a large language model is, I usually jump to the librarian analogy. So if we think of the internet as just a huge library, then large language models are really like the librarian, a librarian who's read all the books in the library. So if you can basically ask the librarian anything about a particular topic, and you're going to get a response based on all the different things that they've read, all the different things that are in that library, and how they respond. Now, the key thing to note is this isn't always going to be perfect, but at least in the case of large language models today, it's pretty impressive. So some things may be a little bit correct or a little bit incorrect, but they're usually well-informed responses that are catered to what we've asked and how we've asked it. So this is also another important thing to me, is how are large language models trained? And the reason I point this one out is it's these kinds of things, knowing how it is doing this generation can be helpful in knowing how we can kind of tweak these things. And we'll see this later on how we can kind of inform the context of what's being generated from these large language models. So this is another analogy that I use. So guessing the next word. So if you're trying to teach someone how to speak and you read them a sentence and have them predict which word is next, that would be kind of a relatively silly thing. There's not a lot of I guess, thought process going into that. But essentially, after each guess, if you give feedback and like have them tweak the correction. So here's or start speaking the sentence. Can you fill in the word, kind of Mad Libs sort of style? Then they give you some feedback or they predict something, and then you make the corrections. Then they're going to learn, oh, okay, this word is a little bit more appropriate for this context because of the feedback you gave them. And over time, if you do this again and again and again, and if we think about large language models doing this billions or potentially even trillions of times, then you start to recognize patterns and notice similarities of what contexts words should be put in. Now, the reason I say this is the context for the large language models and like what words you give it to predict the next word or predict the next series of words is really, really important. So setting this context is kind of a key thing. But the cool thing about large language models is that they've read billions of sentences. They predict words as well as characters. So this is great for like generating code and all kinds of other things. And to do all this feedback that they're getting is from using deep learning patterns. And these are all really cool things. Again, I'm oversimplifying here. I'm sure plenty of the people on this call know a lot more about these details. But this is just where we're going to set some context for those who maybe haven't been exposed to it yet. So this brings us to the question, what can we use large language models for? I'm not going to read out this whole list of things. This is more just to show you that you can use LLMs for so many things. Text generation is probably the most obvious one, where we've gotten really used to using ChatGPT or a variety of other models from Hugging Face and everything to do this text generation. And that's kind of the one that we're going to be focusing on more so here in this talk. But there are many other things. So like summarization or translation, or even just sentiment analysis. I've done plenty of talks on that. Or coding help. If anybody used GitHub Copilot, there we go. Then those things are all based on LLMs, which is super cool. But the one drawback, or there's a few drawbacks rather, with large language models. So one is that the knowledge is general. So we talked about that librarian analogy. They've read all the books, but in the response they're giving you kind of a general response. It may not be very, very specific to what you're asking or what you mean to ask, but it's kind of the summarization of all the things that have been read, distilled down to a particular snippet that's handed back to you. So really domain-specific topics where there may not be as much information, if you will, in the library, then that may be misrepresented in the response that you get. So for instance, if I ask a medical question to a large language model, it may give me the general answer that's available on the internet, but it's not going to give me a doctor-specific response, or a response that a doctor who's done a lot of research into the area would tell me. The second thing, and this is why we talked about the training aspect, is large language models don't truly understand what they're generating back. They're just generating. They're playing this game of, I'm going to just give you a word or a set of words given the context that I've been given. And so there's some statistical things underneath the hood here, or some probabilistic things. And the important thing to note is that these models, a lot of times we talk about how does the model understand this or that. The answer is not really. It's kind of just generating things from the training data it's got. There's a lot of arguments to be had around definitions of things here, but LLMs truly don't understand. They're just generating. And this can lead to a variety of other things. One is being inconsistent. So the model, because the model is generating things based on the prompt that it's given, there's a lot of parameters in here like temperature and other types of things that can lead to inconsistent results. And so this is something that's not bad if you're trying to brainstorm an idea, but if you're trying to execute on something or give somebody, for instance, in our case, if we have a QA system and we want to make sure that we give the correct answer every single time, we don't really want that to be inconsistent. We want that to be reliable. And then finally, the knowledge may be out of date. So depending on when the data set that it was trained on was curated, then this can be problematic if you're trying to answer questions about something that's new. So for instance, in the case of ChatGPT, I pulled this straight from it. The last update for the data set was in September of 2021. So many of the things that have moved on, or for instance, even open source libraries like Label Studio, have evolved quite a bit since, in the past 2-ish years. And so that can lead to a lot of false questions if we just go straight to ChatGPT to answer questions about current events, or even just like current GitHub libraries or whatever else there. So with these things in mind, this kind of brings us to the bulk of our conversation. So that's kind of setting the stage of what we're thinking about when we're using large language models, and the things that we're trying to solve as we start approaching building our QA system. So let's talk about the high level problem that we're trying to solve. So let's build a chatbot. So we want to make a chatbot that can answer questions about Label Studio. So OpenAI, ChatGPT, and even the OpenAI APIs are really good chatbots. So why can't we just use those out of the box and just point users or forward requests through the API to give us answers to our Label Studio questions? So OpenAI, obviously, no doubt, it's amazing at conversational AI, and we could ask all these questions to ChatGPT. But as we talked about just a second ago, the last data set update was in 2021. But the good thing is, according to how we ask the question to the large language model, because it's generating based on the context that it's given, we can actually I guess the question that we have to answer is, can we give the large language model more context so that it can give a better response or more relevant response? And so, for instance, we would love to use the most current version of Label Studio's documentation to give that context to the large language model, still being able to use something like OpenAI's model, so ChatGPT, or just some of the GPT models in general, to predict based on the context of the Label Studio docs, because they provide a lot of detail. There's a lot of good information in there, and that's going to help us answer the question in a lot stronger way. But the question is, how do we decide what's relevant context? So the relevant context that we're going to use is obviously the docs. But the way that we're going to do this is, first we need to grab these docs and actually create a data set out of this. Just to jump back, how we decide what's relevant context is going to come through in the approach to how we build our chatbot. So the first thing, go ahead.
So Jimmy, we actually had a question from the audience kind of about this too. Cole Short is wanting to know, how does this differ or align with the concept of retrieval augmented LLMs? Is it the same thing, or is there some sort of definition of either?
Yep, absolutely. So this is definitely retrieval augmented LLMs.
Great, thanks.
So yes, right, Uncle. So basically, this is exactly what we're going to do. So you're ahead of me, Cole. I love it. So what we're going to end up doing is we're going to grab this data set and we're going to figure out which things are most useful for augmenting our LLM, for providing the context to our large language model so that we predict something that's more relevant. And so the way that we're going to get there is, first we need to grab the data set from our Label Studio documentation. And so this is stored in GitHub, so that's pretty easy to do with LangChain and a few other components. Then we're going to build a document database. So this document database we'll talk about in a little bit more detail, but this is going to convert, pardon me, the document pages that we have for Label Studio into embedding vectors. And I'm glossing over a couple things here, but essentially what we do, what this is allowing us to do is find similar documents to either our question or to other documents. We can compare these in an abstract feature space. We'll talk a little bit more about this in a second, but we're going to compare these things, and then we'll be able to cluster and see which documents are relevant to the question that we're asking. And so that's where vector databases come in. Next, we're actually going to create that chatbot, or produce that chatbot that will answer these questions by converting the question into an embedding that we can put through into our vector database to get the relevant documents back. We're going to grab the top, say 10 or however many we want, most similar documents to our query, to our question as context. And then we're going to, in this case, just for simplicity, we're going to use an OpenAI model, so the GPT models, to provide context for that query, and then get a response from OpenAI after having augmented that query with our data, our relevant data. And this is what it's going to look like here on the right, our chatbot at the end. So rather quickly, I wanted to go through if anybody hasn't used vector databases before, they can be a little bit confusing. So I just wanted to simplify them a little bit. But the main interesting component of vector databases is a lot of essentially you're really just doing approximate nearest neighbor or nearest data point comparisons. That's usually what vector databases are. So you have this feature space, which here we can see it in 2 dimensions with the TSND plots, but we can see it in 2 dimensions where we would be able to grab the most similar, or sorry, the points that are the closest to any particular data point within a certain radius or whatever else we want to do by just doing distance metrics. So this is only 2 dimensions, but we can imagine we have a fixed vector of kind of arbitrary length. So maybe we have 1,000 dimensions that represent all the different intricacies of language and other kinds of things, or maybe much, much more. But essentially what we have, or what we're doing here is we're going to use these vector representations to be able to figure out which things are similar to each other. The interesting thing here is that we can actually use large language models to compute these vectors for arbitrary length text. And so we won't go into the details of how that happens, but essentially if I have a large language model, it's going step by step, sequence by sequence through the words of our model, and the hidden representation, the state and context that's being passed to the next state can be used as our our embedding vector to give us a good summarization of what's in that piece of arbitrary length text. So when we query a vector database, it's basically the same thing. We have maybe embedded all of our documents. We've computed a vector for each one of our documents. We've put it into our vector database, and then querying is taking our query, so like what is Label Studio, and computing a vector of the same size, looking at what's most similar, what's in the radius for that vector, what are the closest 10 documents to that question, and then using those documents as context for our for setting our LLM up for a prediction there. So now we're going to get into the nuts and bolts. So we're going to go a little bit deeper on how we actually built this. Now I've kind of highlighted the parts that we're going to talk about in each category, so we can kind of see as we're building up to the bigger picture. But the first thing that we're going to do is we're going to just grab this data set and ingest it, the GitHub data set of our documentation, and ingest it into our into our vector database to be the retrieval portion for our Q&A system. So we'll see this more in our demo, but basically GitHub is going to be our data set. So we're going to use the docs, which are markdown files in the GitHub repo. And this sort of snippet of code is a LangChain piece of code that's going to grab the repo path, the repo, and then download it, and then check out the appropriate branch, and then load that data. So this is props to LangChain here, just a really convenient and easy way to pull stuff from GitHub. And yeah, it worked amazing. So yeah, it's almost as simple as it looks. And that's, yeah, it's grabbing all the markdown files from our GitHub repo. This does mean that we're also grabbing like our readmes and maybe some other markdown files in there. We're not doing any sophisticated filtering or anything because we think that those markdown files are probably also providing good context. But obviously, there's plenty of things that you could do to filter the data that's going into your vector database and so on and so forth. So building our vector database. So in our case, we have a few different pieces that we need. One is we need to segment our data because some of the documents, some of the markdown files can be very, very, very long. And the chance of that means that we're going to exceed the context length for our large language model that we're using. So what we're going to do is we're going to create almost slices of the document's pages and segment them down to 500 characters. So there's a lot of different things that you could potentially do, have overlapping segments or longer segments, shorter segments. This seemed to be pretty useful for us as a starting point. But yeah, just mentioning that there are a lot of details on how you can split out the data and how you want to basically define documents inside your document database, vector database. The next thing that we're going to do is we need to compute embeddings. So we're going to be, again, this is more for the simplicity of deployment, but we're going to be using OpenAI for the embeddings here. And so OpenAI actually has some embeddings endpoints that we can use directly just to get back embeddings. So the way that we're going to do that is basically we can still use LangChain. There's a component inside our library inside of there to use the OpenAI embeddings. So we're going to use that to get these semantically relevant embedding vectors for each of these chunks, each of these 500 character chunks that we've gotten from segmenting our documentation. So like I said, this is mainly so that we don't have to deploy an LLM locally or talk about infrastructure setup and those types of things. But this also means that swapping this out for a different language model in the future, so something from Hugging Face or something I've deployed myself in my own cluster or whatever else, is very straightforward from an API perspective on how you would do that. The other thing is that we're going to be using Chroma as our vector database. This one also, again, props to LangChain, has been built into their libraries. So it makes this integration super simple. And the other cool thing about this, because we're doing a pretty small example, is that we can serialize that locally and kind of start and stop our program or just experiment with that locally without having to do a bunch of deployment things as well. So we're building a simple application here, but each of these components should be able to scale up to whatever interest we may have. So the next piece that we're going to talk about is building the initial chatbot. So we've up to now grabbed our data set, we've ingested it into the retrieval Q&A portion of the system, which is our vector database by using the OpenAI embedding endpoints. And then we're going to build this this Gradio app, or kind of this user interface to grab things, or to take our user questions and then get the appropriate context for the prompt that we're going to provide to OpenAI again. So we're heavily leaning on OpenAI to give us the embedding vectors and curate a response from the context that we're setting. But that's not necessarily a bad thing. One, it's not that expensive. Not that I'm working for OpenAI or anything like that, but it is a really simple way to get started. And the abstraction point kind of sets you up for, if you're ever wanting to fine tune the model or do something really specific, then swapping that out for whatever you actually want to use there, Llama 2 or whatever else, should be relatively straightforward.
So with regards to OpenAI, we have a question from Harry. When we prompt the LLM, does it have to phone home to OpenAI to create the prompt vector embedding, or can it be done without using the API?
Yeah, so you're exactly right. It does need to, in this case, it does need to phone home. So we are sending our request to OpenAI. Essentially, it's got to run through all the GPU computation that it takes to take the text and run it through the different stages of the large language model to predict the output vector or to predict the response. So it is going to the internet, or like running to OpenAI's servers on their Azure cloud or whatever else. So that is happening. Again, like if you're wanting to run your your large language models locally, or in your own cluster and everything like that, then this component would need to be swapped out with whatever your large language model is. And so this could be a Hugging Face model that you've deployed, or there's a variety of ways to deploy and host large language models. But for this example, it's simpler to not have to go into all the infrastructure about how to serve a model from scratch. But yeah, great question. Thanks for the question. It is going to the internet. So if you have very, very sensitive data that you don't want to be sending over the internet to someone else's servers, then yeah, this is definitely a consideration. Cool. So the last thing I'll say here is once we've gotten to this point, this initial chatbot, we have the ability to take the user's questions. We're going to send it to our, in this case, our Gradio app. We're going to compute the embedding vector with these OpenAI embedding endpoints. That's going to be sent to our retrieval Q&A system, where it's going to find the most similar document vectors to the query that we have. And then that's going to return to our Q&A system, which is going to take the full context, provide all the documents as well as our question to the OpenAI system in a ChatGPT-like way. And then that's going to send the response to our user. Now, this is really cool. Like we've done, we've created a baseline chatbot for just straight from our documentation, and we have this Q&A system that we can use to pretty much answer a lot of the questions, or almost any question about Label Studio. We can even set the prompt to say, I don't know anything about that, when somebody asks something really, really crazy that may not relate to Label Studio. So we can do some prompt tuning that we've added into the Gradio app, and a couple other things around this. But where this gets interesting is when we want to improve this. So in my experience, and like basically most of my life in machine learning, at least, the continuous improvement part has been the real beast to wrangle. And so this is where I'm pretty excited about some of the Label Studio stuff. So how do we improve on this over time? And so this is where Label Studio comes in, basically the way to tune your large language model. Now, tuning can mean a lot of different things. And so really what we're talking about here is we want to incorporate feedback into the system. Now, that can mean fine-tuning the large language model. That can mean curating additional documents, or even just like incorporating the good responses as far as the ways that we want to improve that system. But the ultimate thing is we want our system to improve from a qualitative perspective. So once we've built the system, we actually have no idea how good or bad it's going to be. This could be an indication of, are our docs good or bad? If we just have the assumption that our docs are good, but there's still some older things in there, there's a good chance that it's not going to provide the most high quality results, because our data set was biased towards the wrong things. And this is where incorporating human feedback is kind of the key component here. And this is the case with any domain-specific LLM, is incorporating this human feedback, or figuring out how to incorporate this feedback into the system. So there's a few different ways, and I kind of just alluded to them a second ago, to improve the system. So one way that we could do it, and this is the easy way that we're going to take, at least in this example, is we're going to take all the good. So we're going to take the data that has been run through our Q&A system. We're going to take this and import it into Label Studio. We're going to label these things as good or bad, just very simple right there. And then whatever good responses we have, we're going to add those exact responses to the vector database, so it can be used as context later on. Now, in a medium scenario, we could even say, all right, our human curators can go in and edit the responses specifically, so we can get very, very specific human-generated responses for some of the questions that we think weren't as good, incorporate those. So that's just a medium level of effort. And then once we have enough data, so this is kind of a key component, and the capability to do this, we could even take the large quantity of chat data that has been asked or everything else, and then fine tune our large language model with this data. So this can be a few different. There's a few different ways that we could do this, but basically, that would be definitely on the harder side, and we need enough data to get there in the first place. So usually we probably want to start with what's easy, maybe move to the medium difficulty when the easy thing is only getting us so far. And then finally, when we have enough data, we pivot to the fine-tuning, the large language model at the core level. So the general workflow, we kind of alluded to this a second ago, that we're going to follow is we're going to have our chatbot, and we're going to have users, or in this case, just me, interacting with our chatbot and just generating responses with our Q&A system. Now, we want these conversations or the question and answers to go to Label Studio. So once they're in Label Studio, we can label these. We can have our human curators look and evaluate, are these good or bad? And then sorry, I saw an audio thing. I think we're okay right now. We can evaluate whether these responses are good or bad, and then we're going to take these validated responses and we're going to use those to update the system. So this is just the simple kind of QA chatbot workflow that we're going to work with. So finally, how are we going to do this? Yeah, go ahead.
I wanted to jump in really quickly too, and maybe just check in to see how many of the folks in the audience have used Label Studio, or is this the first time that you've worked with Label Studio? Is this or are you experts at it, looking to augment your workflows? I'd love to hear in the chats down there just about that, because it's curious to see, hear if you're using it and how you're using it, and how you'd like to if you plan on incorporating this sort of thing into your workflows. So it looks like a few people have said that they've used it for a decent bit. Mike Ion has used it a decent bit. Cole, this is his first time. Harry's used it for computer vision models. Yeah, some beginners. So yeah, thank you everyone for sharing your experience levels on this. All right, I'll hand it back to you, Jimmy.
Oh, no, you're great. I was going to say, I'm thinking and looking at slides. So yeah, keep the conversation going, and definitely interrupt if I'm missing anything. Great. So yeah, this is the general chatbot workflow that we're going to kind of go through. So using this Gradio app, this conversational Q&A bot, and then we're going to be incorporating the responses into Label Studio. So as far as how we get those responses in those the prompt response pairs back into Label Studio is actually something that's now available, which is our LangChain callback. So basically, a callback means that you can hook into your, in this case, your LLM application at any particular point. And we want to do that at the time where we're providing a response to a query, or when we get a response to a query. So this allows Label Studio to essentially get the prompt and response after the large language model is executed, and then insert this as a task into Label Studio so that it can be labeled, so that it can be viewed by people who are labeling the data. And this is really cool because, frankly, and this is kind of one of the key components that makes it all possible. So huge shout out to Nikolai for his work on building this and getting this over the line. But yeah, this is kind of one of the cool key components that once we put the small callback inside of our our chatbot, then we can just automatically populate the data inside of Label Studio. So what this means at the end of the day is once our user questions have been using this callback, once people are interacting with the system, all the data, the questions and answers are going to Label Studio. Our annotators can see the responses and see what's happening there. So we can do a couple things. One, we have an annotated data set that's coming out that we can use to tune our model and tune our system. But the other thing we have is we now have a quantitative evaluation for the quality of our system. So for instance, if I have my annotators go through and label good, bad for all these different responses, I can then look at the distribution or the percentage of good responses to bad and see, okay, my system's actually doing 85% good job or 95% bad job in a horrible situation. But this really starts to get us to that point where we kind of bootstrapped. We started with the Q&A system. Now we're able to evaluate how good it is and then know how to improve it over time. And this kind of leads to sort of the bigger idea that at the end of the day, we're not just trying to get a really, really good large language model. We're not just trying to fill our vector database with the exact right things or a Q&A response for every single thing. What we're trying to do is provide a quality system and a good user experience on the output. So we're interested in improving the full system, not just the quality of one particular component in this. And so this is kind of where everything kind of connects together, that this iteration not only gives you a data set at the end of the day, but it also gives you something to do data science with. If you dig into those questions that are being asked, if 90% of them are about Docker, then maybe Docker is the thing you should think on. Or if 100% of them, not 100, if like 5% of them are of the ones that are deemed bad responses are on a particular topic, then this means that people are A, struggling with that topic, and B, maybe the docs aren't showing the things that we need in that topic. And so this is really kind of the key, is that you want to improve the system as a whole through human feedback, not just creating a data set to retrain your model or inserting stuff into a vector database. So we kind of talked about this loosely ahead of my slides, I think, that we can do some qualitative evaluation. There's also some really cool things in the enterprise version of Label Studio, which are some metrics and dashboards that are just built right in. So you can essentially see everything in the same place. But this is, there's plenty of things that we can do. So we can incorporate these good responses. And we talked about how to do this by creating documents from these labeled data sets, or these labeled tasks. I had taste here. But these tasks, and then incorporate those into the chatbot. So with that, I'll pause and we can pivot over to seeing it in action. Chris, any questions or anything that we should talk about before I jump over?
No, we've been seeing that we have a pretty wide range of users, from folks who have used Label Studio before to brand new users. And so when we get to the labeling part of it, if we could just spend a little bit of time too, just talking a little bit about how Label Studio works and kind of its workflow and how the idea of tasks and annotations, I think that would help get a lot of the newer users up to speed too on how just kind of the real power of being able to pull in tasks automatically through callbacks like LangChain, and how that kind of really extends the kind of the power of Label Studio.
Yeah, absolutely. That's a great call out. Alrighty, so here, so I've just pulled up Label Studio. I have an uninspiring one project right now. But just to talk about a couple of things, if you're not familiar with Label Studio, it's really easy to create new projects and even import data from files and everything else. This is kind of the standard way that people typically do it, is adding a URL or just uploading your data set from wherever you are, or from whatever data set you have. And then we actually have a bunch of templates kind of out of the box. So computer vision templates, if you're doing object detection or things like that, natural language processing, that gives us some Q&A components, or text classification, or other types of things. Plenty of things around conversational AI. Basically, there's a bunch of templates that are there And then once we select the thing that say we want to use, we can then save that, and then we have a new project. We'll see how to label here in just a second. But the other cool thing
Yeah.
is we can even provide our own templates. So in this case, I'm using a template that's specifically made for my chat bot scenario. So for instance, I'm going to grab my definition here. And if I paste it in, I can see it immediately. Whoops, I missed something here. There we go. Oh, well, that's what I get for immediately trying to do something like live. But we can even put in our template from scratch just via code. I evidently
Oh no, it
have.
looks like we're missing. Usually
Yeah.
happens is if it's being pasted from
Oh,
like a Word
I know what's
document,
happening.
sometimes smart quotes get in your way.
Yeah, I think that might be what's happening. Or there we go. I just was missing a closing tag.
Missing a closing brace.
But yeah, so we can see this UI preview right here of the style and layout that I have.
Yeah,
So
and
I
this
won't do
is this
anything
is
with
actually
that. Oh, go ahead.
yeah, this is one of the really exciting things about Label Studio too, is it has like it's built this kind of it has this whole markup language that the idea being that we want to give you all of the tools to be able to kind of like build your labeling interface, but really because every annotation project is so project specific that the teams who are putting that together kind of know best on how they want things to look. We try to really build that out to be as like flexible and as useful as possible. And there's a quick question too from Rema: Is Label Studio open source? Yes, Label Studio is open source, and so you could go download it right now. You can self-host it. You can host it on a Hugging Face. Human Signal, the company I work for, also has a hosted enterprise version if you don't want to host it yourself. For great
Excellent.
questions. Anyway,
Yeah,
thanks.
yeah. No, these are great. Yeah, and you're filling in the gaps. I've been in QA system for too long. So yeah, so this is kind of the general interface once we have some data. So I've been interacting with so we have the QA chatbot over here. I've been interacting with the system a little bit and have some example data points. So here's the user's question, and then here's the response from my QA system. And in this case, I've labeled it as this was a good example of a response. And we can see I've labeled 3 different things here. We can click to label all the tasks, or even in some other cases, if we want to predict with a machine learning model, we can connect things into that as well to sort of help prediction models be able to label our tasks as well. So there's a lot of really cool things that you can do here. You can filter on things. You can have different tabs if you want to just view things in different ways. And yeah, import and export. So export's what we're going to be coming onto here in a little bit when we do the tuning of our model. But just to show you kind of the simplicity of this, so I can ask something like, well, let's see, what's something label specific?
How do I access Label Studio's API?
Yes. So getting an API key, is that the question?
Yeah, let's do that. Yeah.
Honestly, that's an excellent question, and something I absolutely should have incorporated here. So basically, when you start up
Oh no,
Label
but
Studio,
let's ask the chatbot that question.
oh yeah, yeah, actually,
Yeah.
sorry, that's oops. Are you satisfied with that question?
Yeah, that looks great.
All right, it's churning under the hood. Perfect. So open your web browser, go to Label Studio's website, log into your account, click on the profile account settings, look for an API key or developer settings, and then click on that option. So I think this is okay. You're not going to the Label Studio website and logging into your account. Instead, you're going to the Label Studio application. But then, yeah, click on your profile and account settings. So if I go to this, whoops, sorry, the profile and account settings, good job. And then, yeah, there's the access token for my local instance right there. And I can copy and use that. So yeah, this is a good question. It did okay, not great. It kind of got us there. But if we go back to our project, what we can do here is if I just hit the sync button, Oh, it's already done a sync. I can see it right down here at the bottom. So in this case, I don't know, Chris, should this be good or bad?
I think it, I would call it mostly good. But I think that this is like, I think this actually calls back to like, one of the things about Label Studio is that so right now this is just a sentiment bot, which is like you rate things. Oh, this is good, or was this, or I mean, like an evaluation, annotation here, is this good or is this bad? But if we wanted to, we could actually go in and add a field onto this, which to provide context for it and kind of like add all of the information that Jimmy was just saying. So you might even be able to say that, like, as part of the fine tuning process, actually provide the answer that you think is right, and then use that to kind of feed back into the to the tuning process. But I'm probably getting a little bit ahead of myself here. But yeah, I would call this a good answer. Like it got you to where
Cool.
you needed to be.
Yeah, and honestly, the thing I love about your response to that more than anything else, now we're just doing podcast style, I guess. But the thing I like about that is, out of all the models I've worked on and everything else, the definition of what's the right label for this data is always going to be like, it's tough to say. And so rating systems, when people are unsure, it's a 3 out of 5 or something like that. Or maybe just depending on what they feel that day. And even labelers, it depends on the time of day sometimes, and like how lenient or not they are with the data labels. But this is where it's really important that not only we're starting somewhere, we're getting some data, but the labels, over time, you're going to even iterate on those labels or on the understanding. And even what's
Yeah.
a good answer right now may be a different answer in the future. And this is exactly what you're saying. Like, we could add a field here to provide some context. We could even allow you to edit the response, or edit the response and then mark it as good. There are a variety of things that we could do to change this labeling template to be able to fit any task. And that's where I think what you said earlier, the flexibility to change and move with your data and with your application and your overall system over time is kind of a massive deal.
Yeah. And Mike has a question about, kind of like the knowledge embeddings too. And he wants to know, how do you know that it's citing the embeddings versus using knowledge from the pre-trained model? Like for, in the example about the API key there, I feel like it's possible that it kept generalizing tokens about finding an API key from documents it was trained on.
Yeah, so it's a good question. There's a kind of a variety of details to go into there. So it is possible that the large language model is definitely biased. That's how you get the usefulness of it. It's biased to the data set it's trained on. Now, if I ask it something about what we have built into the system, at least, is sort of a prompt to only answer things. I need to dig into the code a little bit more to find this prompt, but a prompt that will only respond with the context that it's given, and basically you're doing prompt engineering to try to keep the model from falling back to data or things that it's learned before. So if I say about dogs, I don't know, then basically we get a response. So this is using the GPT type things into the hood, but and I can probably find this. The prompt that we have that we're providing to it is one that is trying to prevent us from answering questions that are outside of the domain that we're interested in. I would need to dig a little deeper to find that. I thought that was going to be a quick thing to find in the code,
Yeah,
but yeah,
but the source code for this is available, we should be able to, you should be able to kind of
yes,
look at the source code and see how that's done.
yeah, absolutely. Yeah, it'll be really transparent. I need to, it would be a not useful effort for me to try to find that for you now while everybody's on. So cool. So once we've clicked this good, I'm going to click submit. So this data has been submitted to the system. And then if I go back over here, I can see, okay, I have maybe 3 things that are labeled, or sorry, 4 things that are labeled, 3 things that are unlabeled. And now say pretend I've done a lot of this. I've generated a lot of human annotations for the data that's been going into and out of my Q&A system, and I'm ready to fine tune my model. So what I can do now is I can export my JSON file. And once I have that, I may have to reshare something here.
Yeah. Yeah, before we kind of jump over to that too, like one of the things it might be nice for people to notice too is that when you look at the Label Studio interface here, you'll notice that there are some numbers underneath the annotations here, and so you have that blue box which total annotations per task. There's a box which is like, have people skipped it? There's another one which actually allows you to have like plug in machine learning backends to be able to like make predictions on what it thinks the models are. And that these are counts right here, like because Label Studio is a multi-user system. And so if you want a large annotation team, you can actually assign tasks to people so that there's like, okay, like you actually want to maybe get agreement between the annotations. And so you can ask your annotation team to like, your entire annotation team to like label those tasks. And so Jimmy and I were debating like, well, is this a good answer or this is a bad answer? I was like, well, that's a good answer. Maybe Jimmy marks it as a bad answer. And you can continue to use that information to do things like use agreement to determine how strong that label should be.
Yeah, that's a great call out. And yeah, we can see that we know who's annotated it. In this case, I'm being cheesy and just doing a default user thing, but yeah, exactly. So I may label it as bad, and Chris may label it as good. And then what that really surfaces more than anything else is that there's disagreement in the labeling teams, and that needs to be addressed, or we need to have a conversation about that potentially. Or if there's millions and millions, then you just go with the summary or the sum total versus each other, the people who labeled it this way or that way, and automate some things there. But yeah, no, it's a great call. It's a great collaboration tool. Saying that from someone who's tried to build labeling applications in the past, and yeah, there's a dream come true on that front. All right, so yes, so we have our chat interface. I'm just going to keep that there, and then now I have my. Is that too small? Let's make that a little bigger. There we go. So these are just basically where I'm running those different, the chat interface and then Label Studio over here. That's not really important, but what we're going to do is we're going to add these documents. So what I'm going to do here is I'm just going to run this add documents Python file. I pass it the JSON file that we just downloaded with all our data in it. And then it's also telling me the persistent directory. This is just the directory where my vector database is being stored. So after I run this very, very simple script, it's done already. It's inserted those vectors and then persisted that database. So then all I need to do now is restart my my Q&A system. And all I'm having to do here to start my Q&A system is run this chatbot Python file and then tell it which project inside of Label Studio that I'm pointing at. And we can find that out from our projects. There's some naming here, but
this is like,
but
yeah, and this is a little bit beyond like Label Studio itself, but this is like comes back to the almost like one of the canonical problems of machine learning pipelines is like, how do you update the model and while it's running and while it's live. And that's I always think it's fun to like, coming from an infrastructure background, I always think it's fun to see like the pipeline like workflows that you do to like, okay, I've retrained the model and I have to start it back up again.
Yeah, absolutely. Yeah, I haven't tested whether it does it automatically, but yeah, I'm doing a pretty hacky interface here to show this. Cool. And then well, we didn't talk about a couple of examples, but then when I start sending the some of the questions or some of the prompts that I've had before, then we'll see the responses that with good labels. So if I even just copy all of this and paste it back in, then we should see a response fairly similar to our good label that we've received before, because those things have been labeled and are now parts of the documentation process. And actually, this I'm remembering this now, and we'll pivot to Q&A in just a second. But the reason I wanted to incorporate this one is if you type this exact same question into ChatGPT, you get a very old answer. So I was going to pull up ChatGPT and run through that, but I don't think that we have time. But the pip install is the same, but then how you start Label Studio is different. And so this is an artifact that's definitely present inside of the data set from 2021. I do believe that was the old way of running Label Studio, but then in the new way, or in the updated way over the past 2 years, it's the context is incorrect. And so so this is an example of like where we're actually very much biasing the prediction in the right ways to accomplish this.
Yeah.
So with that, anything else you want to add, Chris, before I jump back?
No. I mean, I think we're getting close to the top of the hour. So I think that we can start by maybe jumping into some of the questions that people asked. Yeah, that was a great presentation, and thank you so much. And I mentioned before that like the code for this is available. So I've dropped the link into the chat, a link to the examples repository, so you can actually go and you can try this out for yourself. We also have some QR codes up here, so you should feel free to scan those. Go look at them. While we answer some questions. So Harry is asking, are there clear performance benefits to using a vector database for information retrieval, as opposed to just fine-tuning the information itself? Or is it a combination of techniques, generally the best approach?
It's a good question. So if you have the data, there's, I guess, a few different components. So if you have the data, then tuning the model is probably typically going to provide some better results. However, tuning the model can often be an endeavor in and of itself. So are you doing parameter efficient fine tuning to augment your large language model? Training large language models or tuning large language models can also lead to what they call catastrophic forgetting, where you're forgetting the general knowledge that you have and focusing on the specific knowledge, your learning rate settings, etc. Like basically how much you're going to use that new data to bias your model for new things. So it will produce better results, but it's sometimes harder to get to those results, depending. So and also you have to have enough data. If you have a few data points, then it's a little bit hard to incorporate just a handful of data points into something without going a little bit crazy. Parameter efficient fine tuning, PEFT is one way to do this, but that's becoming a pretty popular way. But you still have to set some variables for how much you're relying on the original language model and how much you're relying on the tuned parameters to provide you with your best answer. So I would say overall, it's usually a good practice, or like a good thing to consider both. Going for the easy way first, seeing how far that gets you, and then when you have enough data, and when you're not getting the results that you need, then you need to move on to something a little bit more complex. But keep it as simple as possible for as long as possible.
That's awesome. Thanks. Cole has a question. If we're interested in querying specific portions of documents from our database, are there any special considerations that they should keep in mind? For example, imagine that we have more templatized documents like research papers with standard sections that we want to query on. So yes, there's just kind of a general sense of like, what are the considerations for like kind of, identifying and pulling out the best data?
Yeah, it's a very good question. Ultimately, you're trying to provide the best context. So the more structured context, the better, typically is what I've seen. That being said, this is where you're going to be focusing here, is like in this like splitting of text and figuring out what text to split on. So you may, instead of having this just simple markdown text splitter, you may be digging more into splitting PDFs, and I'm interested in grabbing section titles, or like, heading number 2, if you have a structured document of some sort. These things are all going to be individual components. You may have overlapping context with title and section and then the paragraphs underneath. There's a bunch of different ways that you could curate this. I would say it's going to depend a little bit, but there's definitely a lot of different variables you can play with here. And maybe you even do some combination of things. So instead of just having a chunk overlap of however much, maybe you grab just a bunch of titles. You can even tier the system and say like, oh, if this has to relate to any of these titles, then we're grabbing specific documents. There's a lot of things that you can do here. So I can't say like this is the definitive way to do it, but rather we did a very, very simple thing here, and this can get as complex as you would like. but you can definitely split things out into introduction or discussion. The main thing you need to keep in mind, though, is there is a context length typically, or well, in the ChatGPT case, there's usually, I think it's like an 8K or roughly 8,000 token context. We won't get into what tokens are, but basically pieces of words. And so that's what you want to keep in mind is if you have really, really long documents that you're pulling back, you may overload the context window. And that's why we're using these embeddings and like getting the pieces of these things to provide that context. But yeah,
Yeah.
there's a
Well,
lot there.
yeah, and this is, this kind of leads into a question that Farhad asked earlier, about like, just like how do you like where like locations that you can get some of this data, especially for like if you're trying to target like a particular application, like, and I would love to hear where people are pulling data from, how they're like curating their data sets to kind of be able to like retrain their large language models. Like, do you have any advice on like, Farhad's example is like, I want to fine tune a chatbot to help, with people who are learning English to talk about topics like sports and and for like helping like simulate conversations.
And even yeah, I'm definitely interested in that as well. I was thinking about the same question about how do you know the right data and everything. You can even add more into this, like, or use these tools to build on top of each other. So for instance, maybe I want to list out all the documents that went into a particular query and incorporate those into my data labeling. It's like, were these documents relevant for the query that was asked? And so that could even be part of my labeling process. And so there's a bunch of different things that you can use these building blocks to build up to the system that is going to be most useful for even knowing what documents should be relevant for particular queries, knowing your user, knowing who's querying what, like knowing what's actually most useful for the user, but then even figuring out what are the sources that you're pulling from, where are their gaps, and all that. Again, doing something right and doing something well is a pretty messy process, but having the tools to do it right is going to be key to actually solving the problem.
Yeah, yeah. But it also illustrates something too, just in general about like where you get your data from is like I think one thing that's clear coming into this like large language model and these kind of foundation model worlds is that like owning the data and knowing and like having access to the data is like such a critical component of this. Like we train this Label Studio bot off of open source MD, documents, right? Which you can kind of use and do that with. Like if I were training like a chat bot about sports, maybe I would want to go to someplace like Reddit and maybe read some forums and pull some data out of there. But then can I really do that? Like, because do I have access? Because do I truly have access to the data to be able to do that? And I think it's like it actually becomes a more difficult problem and really shows like having tools to effectively manage your data is like just as important as the tool that can kind of like retrain the bot.
Yeah, absolutely. So I know we're right at the top of the hour, so we may need to
Yeah. Yeah, we
move
should.
on and thank everybody. But yeah, thank you everyone. Definitely check out
Yeah.
the blog and the repo. I'll hand
Yeah.
it back over to you, Chris.
Yeah, and really thank you to everyone for joining us today. I mean, this is a really exciting topic for us, and we're so glad that you joined us. We would love to see you more in the Label Studio community. We have, if you click on the link for Label Studio, we have a Slack channel, which and everybody's welcome to join, and you can follow up with us there with more questions or about the talk in general or about Label Studio. We also are running another one of these webinars next week. It's going to be a little bit of a different topic. Instead of focusing on large language models, we're going to be focusing on vision models and how we were able to integrate Meta's segment anything into essentially an object segmentation model, so that to help out with vision workloads where you need to like essentially just like segment different objects out. So would love to have you sign up for that and join us. And yeah, thank you so much everyone for joining, and thanks to Jimmy for just once again so expertly talking about and breaking down a topic that is pretty complex.
It's been fun. Yeah, thank you guys, and yeah, reach out with questions, and we'll do some more stuff here.